Assalamualaikum and hello everyone. Today we would like to share about introduction of prestressed and precast concrete structure. Before we start, let me introduce our team members. My name is Nurul Farahim binti Azman and my team members are Nur Izzati binti Zulkifli, Nur Atira Syuhada binti Azmadi, Najwa Syahirah binti Nasaruddin and Nur Ashikin binti Ciklah.
First topic, the concept and principle of prestressed concrete.
Do you know what is prestressed concrete? Prestressed concrete is a structural material that allows for predetermined engineering stress to be placed in members to counteract the stress that occur when they are subject to loading. It combines the high-strength compressive properties of concrete with the high tensile strength of steel.
Now, let's move on to principle of prestressed concrete. There are 5 principles of prestressed concrete. First, in concrete, a large prestressing force is applied by tendon embedded to it. The anchoring devices are generally designed for high-strength concrete work. Too high tensile stress are likely to be developing in concrete members, and that cannot be satisfactorily resisted by low-strength concrete work. Stress transfer to concrete is done by and between concrete and tendons. The concrete should have a high strength concrete. Next, shrinkage crack will occur during the transfer of stresses from tendon to concrete. And lastly, high strength concrete has a high module of elasticity, and therefore the elastic and creep strength are very small, resulting in smaller loss of prestress in all steel reinforcement.
What is pre-stressing? To make it easier for you to understand about pre-stressing, you can see the picture before the tendons are embedded. For the first image, when we apply load on the concrete member, the concrete will be bent like this. We can see that the compression develops on the top and the tension on the bottom of the concrete. Due to this elongation at bottom, concrete will get cracked. For the second image, we add some steel bars on the bottom section and stretch it, so that it can resist more of the tension and save the concrete from cracking. This is we call as pre-stressing, and this type of concrete is known as pre-stressed concrete. In pre-stressing, the tendons are stretched along the axis and concrete is poured. After that, the tendons are released the compression at the bottom, which tries to counterbalance the compression due to loading at the top part of the beam.
Topic 2, Prestressed construction works.
Prestressed concrete. In case of big concrete construction projects like bridges, steel reinforcement bars alone won't be sufficient to provide the necessary tensile strength. In this case, prestressed concrete is being used. In prestressing, the rods or tendons are stretched along the axis and cement is poured. Later, when the tendons are released, the compression is generated at the bottom, which tries to counterbalance the compression due to loading at the top part of the beam. The principle behind prestressed concrete is that compressive stresses induced by the high-strength steel tendons in a concrete member before loads are applied. This will balance the stresses imposed in the member during the service. Prestressed concrete can be used for the construction of roofs, floors, walls, and bridges with longer unsupported spans. Prestressing is generally done by two methods, Pre-tensioned concrete and post-tensioned concrete. Pre-tensioned concrete. Pre-tensioned concrete is those in which the tendons are tensioned before pouring of concrete. The tendons are initially tensioned and anchored at both ends, and then concrete is poured over it and cured. When the concrete attains desired strength, the tendons are released and projections are cut out. The pre-stress imparts into beam through bond action. Post-tensioned concrete. In post-tensioned concrete, the tendons are tensions after the concrete is poured. Initially, the concrete is cast around the sheathing. The ducts are formed in concrete in which tendons are placed. After the concrete is hardened, the tendons are tensioned by hydraulic jacks and anchored. In case of bonded type tendons, the duct is grouted with sufficient slurry. In the unbounded type of tendons, grouting is not necessary. We will learn about this later. Thank you for watching. Stay tuned. The best is yet to come. Kindly do like, share, comment your views, and finally don't forget to subscribe our channel.
The summary from this video: prestressed concrete can be used for the construction of roof, floor, wall, and bricks with longer unsupported span. Prestressing is generally done by two methods: pre-tension concrete and post-tension concrete. Initially, the concrete is cast around the sheathing that are formed is concrete in which tendons are placed. Prestressed concrete to be produced whereby tension rods are put in place first and tightened, followed by concrete pouring. Then compression can be applied after pouring concrete using bond. They are tightened or the concrete is dry. Prestressed concrete increases the quality, strength, span of the structure. Since it is cost effective, it is used readily on recent days.
Topic 3. Precast concrete versus conventional in situ construction method.
We are going to task 3, which is which one is more preferable between precast and in situ. Due to this category, which first category is casting category, precast is no effect with climate changes, while in situ is change during the weather condition, which is can delay or not. For cost category, precast is less cost because the cast can be reused, while casting in situ need new cost due to new production on the site. For worker and machinery, precast only requires skilled worker, while casting in situ need more labours, which is skill and contractor. And for the strength category, precast have high strength. It can resist on high strength, while in situ, the strength depends on the site condition and resources available. For time of construction category, precast is speedy construction possible as soon as possible, while in situ need more time consuming because it need to be mixing on the site, make the mold on the site, which is required more job, and this is required more time. All our justification can be proved on the facts from article, which is first article is stated about the strength. In first article, it says that precast concrete buildings are often more durable. This is because comparing to cast in place, precast have longer lifespan and service period. Second article is comparison between the costs of precast and precast and in situ, and the article says that cost in precast is less than cost in situ. The last article is a comparison between time, because it says that compared to cast in situ method, the precast method consumes less time because the prepared materials and elements are delivered just in time and placed on site, which reduces unnecessary handling and equipment use. Overall, from what we observe, we are preferable precast than casting in situ.
Topic 4. Environmental effect.
Do you know why precast concrete can reduce carbon dioxide and global warming issue? Precast concrete is reinforced concrete that is cast and assembled away from the construction site. Precast concrete has been discovered to be a renewable building process that improves productivity and reliability while reducing environmental damage and construction site. Many researchers have proven that precast can reduce global warming and climate change compared to conventional concrete, where conventional concrete is cast at the construction site. The majority of recent research have only looked at environmental effect at the manufacturing level in terms of carbon reduction related to reduced building waste. This is the example from article by Wen Kai Luo 2018 for both cast in situ piles and precast driven piles, and article by Dong 2015 for precast beam. Example 1 for article both cast in situ pile and precast driven piles. Precast technique can reduce global warming and climate change due to the improved work efficiencies and waste reduction compared to conventional construction technique. According to the findings, precast in situ construction will achieve a 3.8% reduction in greenhouse gases GHG as compared to traditional construction. The emission distribution from equipment is reduced in precast pile compared to cast in situ pile. This is due to the most of the precast material entailing less equipment uses during the installation of pile compared to cast in situ pile. Example 2 for article Precast beam. Concrete has been identified as a high carbon material, with cement contributing for 5 until 7% of global anthropogenic carbon emission. The on-site construction method is another source of carbon emission, which is primarily caused by fuel consumption in heavy machinery and material transportation, embodied carbon in temporary materials and waste management. Jalen has reported the uses of precasting method can lead to 52% of waste reduction and 7% of timber formwork reduction. Conclude that precasting method can reduce carbon emission as compared with cast in situ concrete.
Thank you for watching. Don't forget to like, comments, share and subscribe. Turn on the notifications for the next videos.